Okay, we go for a quick one for today. And this one will relate to your report. So you can start preparing document about the go-kart projects. Okay. Now, when you solve problem-solving methodology, especially in design process, so we will use the following procedure. So I'll give you all the answer. First, you define the problems. Second, you gather information. The third one, you look for alternative solution. Then you evaluate whether it did sound or not your solution. Then you communicate your results. Now, basically in your report or your presentation later on, you need to go look for the problems. For example, problem means you're focusing on go-kart design, for example, all right? And just now I did show you what are the area that you need to design, okay? So you look at the problems. What are the area that you need to look at? That is your problem area. Then you start gathering information, okay? You look for books, you look for website, you look for standard, how people design works, and this one fall under literature review. Okay, so problem, literature review, then you go for solution. You come up with a design, then you start design 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then you evaluate. There's some evaluation criteria for your conceptual design 1, 2, 3, 4, 5, 6. Just now I show you the sample of report just now. Then at the end, you come up with the final design. Okay, by the end of semester, during your final presentation, you communicate the results. So we will practice this problem-solving methodology in your capstone design 1. And also we will apply the same procedure, same methodology. Methodology, the word methodology means method. I come with the word of method. So the way you're doing things means methodology. So we will practice the same thing, but we will input different content inside here. Okay, let's look at first example. So maybe you are the designer, and the first scenario is that maybe I forget to hidden this one. So maybe this is your project sponsor intend to see. Maybe your project sponsor propose you want to just build a rope chair that can give fun to the children. So when children come under this tree, they can swing around, they can step on the stair and swing around, have fun on it. So maybe the sponsor communicate, okay, go and build a rope chair. In the idea, sponsor have this idea, but maybe the sponsor do not give the drawing, but you just verbally tell in the phone, can you help me to design a rope chair, something like that. Okay, so it give you a description. It must be so the length must be able to reach by the children. The length should be practical for the children to play, must be safe to play, and so on. But the sponsor do not create the drawing. He just verbally say, oh, this is my specification. Okay, so it will be the same when you conduct the survey later on. So when you set the question, the survey, you get the reaction, the response. So you can't normally when you conduct an online survey, you didn't tell your responder to give you a drawing, right? No, right? Normally you just take yes or no, 1, 2, 3, 4, and so on. But later in one of the class, I will teach you how to set the survey paper. Okay, so first scenario, you start with something that propose, okay, let's build this one. Okay, now for example, this project, I'll give you an idea. Okay, let's build a go-kart as your project. So initially, I give you some photo, I give you some concept and all this. So basically, I give you the idea of what is expected already. Then there will be one scenario add on that there's a specific specification in the project's management. So the project will request, or you need to use tree rope to build the swing, the rope stairs or the rope seats like this. So there's a specific specification that, you need to use tree. So as you move along the projects, when you look at the handbook, you look at the race standard, you look at the what is go-kart definition by textbook, and then you go into go-kart tournament, there's some specification, like what is the maximum weight of the total go-kart, for example. So this one will narrow down your design later on. So this will be another add-in information for you when you design something. First, somebody will give you a project and they give you the rough direction. For example, I give you, let's do a go-kart project. So this one normally you will initiate in here. Then it will follow by additional requirement. For example, in this case, you see this just an illustration. So for example, when you do go-kart, or you found out that go-kart have a lot of regulation under different category. Right, different weight and so on. So you find out, okay, this one. Then I set into this category. For example, the power of the engine is below what? So that one. Okay. So you need to use that engine. Then another one is that maybe you are viewing your design from manufacturing plant. So maybe manufacturing, they want to build something that can build very fast to produce, because in production floor, they want to make it very fast. So they will come up with a design. Same seats on the tree, but more easier to make. Okay, so you compare to the original idea, and from the production floor, maybe they want build something that can complete faster. Okay, and another feedback. This one maybe you don't see this one. This one is, when you get my slide, you'll see. So this one is maybe on the user side. On the user side, they chop the tree and they build something very bombastic. You know that sometimes when you ask people what they want, they give you something very innovative, very creative. So for example, you ask someone who is not in the industry, let's say when you conduct survey later on, you need to filter your answer, because sometimes your answer, you get someone who is not in that field, or they answer the question underage, means the questionnaire you send out answer by some children. So they just simply click and then you get the wrong data. So sometimes you get data like this. Right? Somebody suggests you to chop the tree and then give some support and then hanging the rope so that it becomes a chair. So you need to be careful on your input. Sometimes you get this scenario during your data collection. So be careful when it comes to survey later on. So you'll get something like this. You need to filter up those that not achievable or not practical. Another one is that maybe this one from the user, right? Because the sponsor, original, they want to give fun to the children. But maybe the children, what the children want for this originally, they just want a single tire with the rope, and they can have fun with this one. So this one is what the user want. So as you can see, designing process, it can be a loss of angle you can look at. So you need to carefully choose, or when you come to design, you need to carefully choose your process, and even you need to communicate within all the parties. So what is useful, what is important, who sponsor you, and then what is the end user want. This is what the children want. And this is what the original, the sponsor, he want to have fun, give fun to the children. So this is what the original suggestion, but this is what the children want. So you need some balance between all these. Okay, so this is just an illustration of scenario during your planning process. Okay, so Individual have different perspective. So, for example, Capstone Design 1, you have a group of 3 members. So 3 of you have different perspective. So when you discuss about the projects, please remind yourself during the discussion, don't feel offended when people reject your idea or when people disagree, right? So maybe your friend just from a different background, he have experienced that before, so he tell you what he experienced, okay? So this is one of the way when you communicate between team members. So you have to understand there's no right or wrong in design. It's just that from which perspective you're from, okay? Yeah, right. So another chart just to show you, there's a design paradox between design knowledge and the design freedom. So what is the paradox between design knowledge and design freedom? What I mean by design knowledge? Design knowledge means you know about that particular things. For example, I take a go-kart project as an example. So design knowledge means that you know very well how to design a go-kart from the screw to the tire. So you know everything about the go-kart, means the knowledge, the science behind the design. Another one is design freedom. Design freedom means what are the flexibility that you have. For example, you can change the wheel size, you can stretch the vehicle length and so on, right? So this is a freedom. So there are two. We need to look at what happened to the design knowledge and freedom when we discuss about this. Is just an illustration, and the scenario that you will face in Capstone 1 and Capstone 2. How to read this graph? Okay, now you have 2 lines here. One is design freedom. This is design freedom line. This is a knowledge line. As you can see from the beginning, and then you plot the percentage and the time, the time of the process. Let's say we start with 0. The 0 means you start with the new projects. When you start with a new projects, your design freedom is maximum, meaning you're free to start from anywhere, any angle when you start the projects. And you have little knowledge about that projects. That's why, as you can see here, sorry, my finger cannot go further because of my green screen limitation. As you can see here, the origin there, 0. When you start the project, the freedom is 100%. Means you're free to give your imagination what you want to do, and your knowledge about the issue or the design is 0. And as you grow, as you build your projects from time to time, let's say you build from the first day about go-kart projects, you're excited and you have a lot of idea. So you know nothing about go-kart. So you have freedom to design. But as you learn more about go-kart, that means you see the line of knowledge is growing. As you learn through, as the time increase, the knowledge about the projects increase. So you know more about go-kart, you know that, oh, there's a rules, there's rules in design, there's guidelines for go-kart. For example, the length, how you calculate the length, what is the comfortable design, what is ergonomic design about the go-kart. So you know, as you know more, your freedom in design will reduce. Okay? As you know more, you know that, oh, I cannot design this way. I have to follow this one for safety. Or I cannot use this material because of the environment concern. Or I cannot use this one because it's very dangerous and it will create the component will snaps. Or when you transmit the power, if you use this mechanism, it will not work. So as you grow your knowledge, the freedom in your design will drop. Okay? So as you grow, if it takes more time to learn more new things, and near to the end of the projects, so let's say this one is your project time. So let's say this one is your capstone design. Capstone design 1 and 2, you combine together. So as you can see, during Capstone Design 1, you have more flexibility. You have more flexibility. However, as you learn more things, as you progress, the freedom will drop. Means you cannot simply change one thing to another. For example, what you design in Capstone Design 1, it will affect what you do in Capstone Design 2. So when you already finalize the design, when you want to do Capstone Design 2 later on, and you want to change one of the parameter in the design, it will take a long time for you to convince yourself and also convince your team member. All right. So you need to choose carefully during this semester or this Capstone Design 1, so that when you come to Capstone Design 2 later on, you can see that as you learn more, the less you can do about the design. Means the freedom will drop as you reach the end of the projects. So this just have a mental mental preparation about design freedom and design knowledge later on. Okay, so this one you can read. Basically, I explain all the points. And let's go for one. One, then we stop. So design process, there's a flow chart here. So as you can see, the whole design process consists of conceptual design, and then continue with embodiment. Embodiment means you can see this one as a skeleton. You want to build a robot, it will be like a skeleton. So conceptual design will be your skeleton. The bone of your robot. Then after you've done your conceptual design, you will follow by embodiment. Means you add muscles, you add motor to the robot bones. So this is embodiment. Then at the end, you come up with the final design. Okay, so they are process. We go one by one. Today we're going to look at the first one because of the time we have. Okay, so we look at conceptual design. Phase 1, we have 3 phrases here: conceptual design, embodiment, and detailed design. Okay, so what is conceptual design? Conceptual design, you have a few phrases under conceptual design. You define problem, you gather information, you come up with a concept generation, and evaluate. Again, I show you the sample of the report just now. You need to prepare a report by following these steps. So start from today, you can start doing some paperwork about your report, and then you start gathering information already. So today, your homework is to define the problems. Okay, we look at the first one, define problems. So you need to identify what customer needs. Okay, during define problems in your report later on, you need to do survey. Okay, you need to do survey. You need to, for example, Capstone Design 1, we are doing a go-kart project. So you need to understand what is the user needs. As a go-kart driver, what is their needs? In the competition, what are the rules that they will follow? Just a general rules. You don't need to go deep into detail. Just you know that in go-kart, there's a rules there. So what are the general rules? Maybe 10 rules, 10 general rules in go-kart. Okay, what are the size? We are focusing on the design, go-kart design. Don't go until the detailed rules on the whole set of go-kart. No, just focus on your go-kart designs rules. Is there any rules there? So you need to go and look up from today onwards. Okay. So you need to communicate what is the rules or basic design of a go-kart. So from today onwards, you need to go and find information about go-kart. What is the basic component of a go-kart? What is go-kart, right? So what are the rules? Is there any category in go-kart competition? Something like that. So from today onwards, is your homework to go and find all this information and then share among your group member. Then when it comes to presentation later on, then you present in the presentation. Okay. So this is one. Communicate then with the design team. So understand what you need to design, or what is the basic fundamental rules that you should have. Okay, so when you come to detailed design later on, you know, oh, this is the direction we want. Okay, so today onwards, again, your homework is to find information about go-kart. What are the basic design? What are the components? What are the name of a go-kart? All right, if you break a go-kart, there's a name for all these components. At least you know all these components. All right, so this is the homework of your for this week. Then you create a statement. You create a statement during define problem. You create a statement so that to describe what to accomplish, meaning your objective. All right, your statement or your objective to meet for Capstone Design 1. All right, so it involves a few things. Means under problems definition, there will be a statement. A problem definition actually is a statement. So what does this statement about? It's about what you need to accomplish and focusing on the needs of the customer. In this case, you change the customer to go-kart regulation or go-kart design, okay, in that context. So you will do what are the existing products that I'll just show you some. So you need to look at what are the existing design. If you have money, if you want to buy a new go-kart, what are the company they are producing? What is their design? So you start looking at the product in the market. Then, is there any specification or not? Look for specification. And then, is there any constraint or not? Any trade-off? Is there any limitation? Limitation here meaning it can be rules or regulation, because if you go to go-kart, there are some category. So under each category, there are some limitation there. So from this week onwards, you start looking information about go-kart. So by the end of Capstone Design 1, we expect you to able to answer basic question about go-kart. Right? Because all these questions will come when you showcase your products. So the visitors or maybe parents will come and ask you something about go-kart. And this is the phrase during your conceptual design. This is the first phrase that we expect you to go and find out. So you should able to answer question like, this design is under what category, or how do you begin, or is there any company that are selling? At least you should able to answer all these general questions. Okay, so this is for problem definition. And then, okay, we stop here. So we in this class, problem definition means a statement, and what is inside the statement? It involves what are the analysis about the competitive products, what are the specification, and what are the constraints. So this basically about when you find information about the problem definition. You define the problems. Okay. So your context in Capstone Design 1, you define what is go-kart design. You define what is a design, what is a go-kart, what is the rules, what is the regulation, or what is the limitation. Indeed. So maybe you can look at a driver perspective. What is the go-kart driver economic and all this. So if you talk about engine or category, what is 150 cc? What is 200 cc? What does that mean? So all these are terms you should know. Okay, so I stop the recording.